Another example of finding a derivative using the first principles. Let us look at the function 1 upon x, the reciprocal of x. What do you think would be the derivative for it? Let's just figure it out. Now the function is 1 upon x. Now 1 upon x, if you look at diagrammatically, what will it look like? Diagrammatically, 1 upon x will be a function of this sort, okay? A hyperbolic function, okay? It will look like this. So say I am at point P. Say I am at point P and I'm looking at the slope at point P. So that would give me the derivative, right? So I plan to shift from P to Q, okay, and see the change in x. So this will be my change in x. This will be my change in x. If I'm moving from P to Q, the x quantity decreases and the f quantity increases. The f quantity increases, okay? And that's the change in f. That's the change in f, okay? The derivative will be change in f upon change in x as change in x goes to 0, okay? As it becomes minute and minute, so that, you know, P and Q, point Q is coming towards P, okay? Point Q is coming towards P. So now look at the calculus of it. So using first principles again, first of all, what I need to know? I need to get the difference quotient, okay? That's my difference quotient. So once I have the difference quotient, what I have to do? I just have to plug in the values of fx. Now fx naught equals to 1 upon x naught. F of x naught plus change in x would equal to 1 upon x naught plus change in x, okay? Whatever is in the input comes out as a reciprocal. That's what it means. That's what the function 1 upon x means. So just plugging in the values out here. So 1 upon x naught plus change in x minus 1 upon x naught upon change in x is my difference quotient. Now what I can do out here is in the numerator. Okay, let me just take out 1 upon change in x, okay, outside. In the numerator, there are certain things happening. In the numerator, to figure out this difference, I need to take LCM. So, okay, so I will take the least common multiple. So I'm gonna just make the denominators same and then try to subtract. So making the denominators same out here, the denominator becomes x naught into x naught plus change in x, okay? So here over x naught plus change in x, I get x naught minus, and here where the denominator was x naught, I get x naught plus change in x. Now we will just open this up. What will happen? X naught will cancel out x naught, and what will remain is essentially minus change in x. Minus change in x. Now next step, minus change in x. Change in x, as you can see, will cancel out with change in x, and what will remain is essentially the denominator out here. So minus of the denominator out here. Next, what we need to do is to see what happens as the limit change in x goes to 0. So the second part is taking the limit as change in x goes to 0. Change in x goes to 0. Change in f upon change in x will turn into 1 upon x square. Where do I get it from? I get it from here. Plus x naught into change in x. So if change in x goes to 0, this goes to 0, and what remains is essentially x naught square. So minus 1 upon x naught is something that I get. So my slope f dash x naught is negative. My slope is negative. So what does that imply? That implies that, as we will keep on increasing x, as x tends to infinity, what will happen? The slope will become less and less steeper, okay, as we move on this side. The slope will be less and less steeper. It will almost, turn like flat, okay. It will be less and less steeper. So slope at x naught is minus 1 upon x naught square, okay. So in general, for any function, it will be 1 upon minus 1 upon x naught, x square. What would be the tangent line? What would be the tangent line? The tangent line is y minus y naught equals to m x minus x naught. So I can just plug in the values here. For m at x naught. M at x naught is minus 1 upon x naught square. So I can just put it here. And y naught, as I've written here, is nothing but the function at x naught, which is 1 upon x naught. So I get the equation of the tangent as y minus 1 upon x naught equals to minus 1 upon x naught square x in x minus x naught, okay. Or I can just put it like y equals to 1 upon x naught minus 1 upon x naught square into x minus x naught. And that's the equation of the tangent at point x naught.